Um, I want to start out the introduction to this video by showing you uh, a clear example of the two structures that I'm looking at. In green are the vectors. What that means for the inner ghost numbers, which are all purple. There should be a 27 there, 27 back there, 36, 45, 36, 36, 27. And these inner ghost numbers are made up from a combination, in addition, of the 6 numbers at each cubic opening, the 3 primary numbers and the 3 secondary numbers in orange, the 3 primary numbers in blue. These 3, 4, 5, for instance, and 2, 1, 3 add up to be 18, and that's how you do all the other cubic openings. So this 18 is smaller than 45. So it's a vector. It has direction from low 18 to high 45. Same as with back here, 27 is low compared to 36 in front and bottom. Right here, which should be a 27, is low to 36 back here. And 27 down here is low to 36 up here. And so that's just one of 4 structures, vector structures. And I'll go over the other ones. And now this is the 369 structure as a box, because if you numerologically reduced all these purple inner ghost numbers, 18 reduces to 9, 27 would reduce to 9, 36 reduces to 9, 27 reduces to 9, 36 back here reduces to 9, 45 reduces to 9, 36 reduces to 9, and 27 reduces to 9. So that forms a box that outlines with a dotted line, a box, just a box of these inner ghost numbers. And that's, again, one of 4 different types of 369 numbers, a box form. Okay, now I'll go up here and let me put a light on this. I tried to categorize all the 4 different types of vectors and the 4 different types of 369 shapes and these substructures of the inner ghost numbers. And on these ghost numbers, magic ghost number cubes, I didn't bother with the outer cube, because the inner cube is where it all takes place, with the inner ghost numbers in purple. And again, you get these inner ghost numbers in purple by adding up the 3 primary numbers at this cube opening and the 3 secondary numbers, which are orange. The 3 primary numbers are in blue, and those 6 numbers add up to get 45 at this angle, at this cubic opening. So anyway, this is 3 vectors up. That vector goes up from 27 to 81. This vector goes up from 45 to 63. The vector back here goes up from 45 to 63. And this vector goes down from 45 to 63. So that's just 3 vectors up, 1 down. And they have mirrored images. If you flipped it around, you would have one vector up, 3 vectors down, stuff like that. So some of these are repeated in mirror images when you rotate it, or rotational images. And the box here, well, I'll go with the vectors first. That's number 1. That's one example. This is the second example, all scalars. There's 9 as the inner ghost numbers all around. So this is not the same as a box. As numerologically reduced, it is a box. That's the other structure type, completely other structure, 4 structure type. But these are all scalars. That means that 9 and 9 are equal, so it doesn't have no direction. So that's a scalar, not narrow. And all these are 9 at all these different diagonals. So that's all scalars. That's another vector type. A third vector type. Let me see where I listed that at. Third vector type is 4 vectors back. 18 goes up to 54, 30 arrow to 42, 33 arrow to 39, and 21 arrow to 56 back here. And they all point backwards. But then again, there's different rotational symmetries that could make all vectors point upward, all vectors point back, all vectors point left, point right, point front. It's rotational symmetry. Now the fourth type, vector, 2 scalars and 2 vectors down. If you look at the green arrows again, there's 9 going down to 21. That's an arrow going down. That's one vector. 9 up here going down 21 back here. And then you have 15 and 15 and 15 and 15. Those are 2 scalars. And so this has mirror or rotational images too, rotational symmetry. You could have 2 scalars, 2 vectors up. That's its other rotation. So those are the vector systems. Now in purple, I list the 369 shapes. 3 vectors up. No, in green I list the 3. No, and I did that backwards. No. 3 vectors up, 1 vector down. Green should have been the purple ones. Okay, number 1 is box. And these are all numerologically reduced to a box. 45 is 9, 27 is 9, 63 is 9, 45 is 9, 63 is 9, 45 is 9, 81 is 9, and 63 is 9, so it makes a box. That's one 369 shape. Let me see here. The number 2, parallel sheets or parallel planes. You have the 9s numerologically reduced for 27, 45, 45, 63. Then down here you have the 6s reduced from 15, 33, 33, and 51. So 6s form their own plane and 9s form their own plane, and they all have symmetries. Left plane, right plane, up plane, down plane, back plane, front plane, I think. Yeah, I think I got them all. And then the 4 is intersecting sheets or intersecting planes. Or no, 3 is intersecting slanted parallel triangular sheets. And these have 6s, reduced 6s as a triangle in the back facing down. And these 3s are a triangle in front facing up. And there's a 9 that intersects diagonally through both of them. And those are slanted parallel triangular sheets. That's the third example of the 369 shapes. And the last example are intersecting sheets or intersecting planes. You have 3 and 3 up here and 9 and 9 down here, so that forms a plane crisscrossing with the axis right here. Then you have 6, 6, and 6 and 6 crisscrossing that plane. Again, the common axis is right here. So it's hard to separate them because one type of shape interacts with another type of vector system. So it's hard to categorize these when there's no clear cutoff for each type of system in these deeper substructures. But once again, these show the shapes of them. These are all 4 vectors, all 4 scalars for the vector system. 2 scalars, vector up or down. 3 vectors up or down, or 1 vector up or down. And these are all 4 vectors in one direction. These are pointed upwards. And then for the 369 shapes, you have the boxes, you have the parallel, vertical, horizontal sheets. They can be vertical or horizontal. That's it. And then the vertical or horizontal intersecting sheets. And then the slanted triangular parallel sheets with a 9 diagonally across through them. So I hope I interest you in these different types of 2 basic substructures of the integral number system. Well, thanks a lot.